Hi, welcome to our lecture about how I plan my shoulders arthroplasties and how we're going to do it in life in a very practical way. So this video, we are going to show how I do my 3D planning for shoulder arthroplasties. We are going to show first how we can use a free software from a company called Exactech. It's the Equinox planning software to plan an anatomic total shoulder arthroplasty. And then we are going to show how can we plan a arthroplasty or actually any procedure in 3D using free software to plan a reverse arthroplasty. So let's go to the first software. For this lecture, we're using the Equinox planning software. This is a software from the company called Exactech. It's free. You just need to log in. You just need to ask for your rep, and you can use for any surgery. So it's not only for your Exactech surgeries. You can use the software for free for planning any arthroplasty. So you just have to log in with your login and password. And here we have all our patients. We are going to create a new case. So let's click on this plus. And now we are going to import, okay, the CT scan. So the CT scan is the DICOM files from the CT scan. So we can only plan with CT. There is no other way. So MRI, no, we cannot plan with MRI. So only CT. So we download the DICOM files to any folder in our computer, and we upload here to the software the DICOM files. So it will upload. We can select which view we want, of course, the axial view, and it will generate a preview of the CT scan that we're going to check if everything is correct. So the step number one is just to check if the preview and the image and the CT looks okay, and we can go on further to proceed to our analysis. So let's say this is the left shoulder. So we have to click to make sure it's the left. Now we can check if the CT is okay, if there is no problem. Okay, just that. Go next. We're going to put a patient ID. So we do not suggest to use the patient name. So we're going to use Athens Shoulder. We have to put a date for the surgery. Let's use, okay, there's no problem. This is just a warning. And here is something that's important. We have, if we want to go for navigation, so navigation for the Exactech implant, we have to choose this Exactech with GPS. But if we're going to do the planning only, we go to planning only. That's what we're going to do. Okay, now the system is uploading. Now we can start using our software. It's very simple, very quick. We just have to do these steps to make sure everything is correct. Now we have to provide the system some information about the anatomy of the patient. This is something that is different from other plans, other softwares. It's not fully automated, which I like because I'm telling the software part of the anatomy of the patient, and not the software is deciding for himself, and I cannot argue with that. So we have to choose here the center of the glenoid and the trigonum or the os trigonum. But you don't need to be precise because we can correct that later. So number one, center of the glenoid. Number two, click in green, the center of the scapula or the trigonum. Now we are going to do the correction. So as you can see here, we can see a 3D representative of this scapula, and we have the points. So now we can use the axial and the coronal cuts to check if the position of these 2 points are correct. So I'm dealing here with the center of the glenoid. Let's move. So for me, this is very important to make sure I'm choosing the correct glenoid. I'm choosing the real glenoid and not the osteophyte as reference. So that's something that I like a lot. And the same for the ostrigonum. As we can see here, it's a little bit inferior. So we are going to change the orientation of this scapula to make sure this green dot is in the center of the ostrigonum. And this will be how we select the inclination of the scapula. So this is the zero inclination, or the anatomical zero inclination for this scapula. If you want to change, if you don't desire, or if you understand that that's not the zero, you can move this inclination to match what you think is the normal scapula. So we use the center of the trigonum as reference for our glenoid. So that's it. It's very quick. We just need to do this once. Now we tell the software where the glenoid is, the anterior, posterior, inferior, superior. Very quick, very simple, just to make sure we are in the correct position. 1, 2, 3, 4. And now the software will provide the reconstruction of the glenoid. So here we just need to check if everything is correct. Okay, if there is some artifact, we should go back. Correct. It's very rare to have a problem. And now the software is asking if he understands the correct position of the scapula. So he's drawing in blue. So everything is great. Just click validate. So we are validating this is a correct information. So for that, this is what we have in the software. We are going to plan a anatomic. So let's change over here for anatomic. Okay. Now we have the anatomic implants to use. The first thing I do, the first step I do in the software is to check the measurements of this patient, the retroversion and the superior inclination, and I like to check if the measurements are correct. So I click on this button right here, and now I can see where the software is using as reference for inclination and for retroversion. Sometimes we have osteophytes like over here, and we have a retroversion that's measured not correct. Sometimes we have osteophytes over here. Imagine the software used this osteophyte as reference and the inclination would be not correct. So I always like to check if the software is doing the measurement as I think, or as a surgeon, I understand this is the neoglenoid or the paleoglenoid, where it's the glenoid of the patient, or it's using osteophyte as reference. So I can do my checking here. So for me, this is what the retroversion of the patient, and this is the superior inclination, so very mild retroversion and inclination. So now we have checked. Now we're going to choose the implant we want. This patient has very little problems, very little retroversion, so I can choose any implant. Let's go for PEG implant. And first step is to check for the size. Have the medium size, we have the small size, large or X large. So this is pretty much standard for all implants. So it's very easy to plan for even any other implant. So we can choose for small or medium. In this case, it seems like the medium is a little bit big. Let's go for small. Okay. Now I'm going to orientate the implant to the anatomical position of the scapula. So I'm going to change views for this axial view, like as you can see here. And now I can see all the implant here. So let's move the implant a little bit deeper, and let's change a little bit the version of the implant, okay, to make sure we have a good fitting. So 2 degrees of retroversion seems to be good. We are not checking yet the inclination. I'm just checking if we have a good position of the implant, if the pegs are in good bone, as we can check here. Very good bone. Now let's see from the side. And now I can check the depth of the implant and the inclination. If I want to change a little bit the inclination to have more, the position to be more accurate, I can do it. And we can check here that this has 89 degrees, 89% of contact. So a very good contact bone. If we do a little bit more deep, and we can see that's very okay for me. We have 100% of contact and everything seems to be great. Now we can uncheck here, and this is the position of the implant we want. If the patient has a retroversion, we can use augmented implants, just like a 8-degree augmented implant, as you can see here. So we can correct retroversions very good with this implant. So this is the choice that we have to do with this software. So let's move back to what we are, 100% of contact. And this is how I do the planning for a anatomical shoulder arthroplasty. Okay, so when I do that, I go to the surgery, I print some screenshots of this to make sure this is the correct position, to make sure this is what I aim for the surgery. Principally when we have revisions or other cases that are more complicated. And this is very important to make sure we are doing, or we are choosing the correct implant for the patient and not going for reverse. If we want to do a reverse, that's more complicated because the reverse is very specific to the Exatec reverse. So we just check here for reverse, and now we can choose the implant. I'm going to a standard implant. As you can see here, the implant is a little bit inferior. So let's move it a little more superior to the edge. This patient is a small patient, but I'm going with that implant. I go again for the axial view, where I can check the retroversion, and if the central peg is in the correct position, I'm going to move it a little bit more posterior, like that. Let's check if everything is correct. Let's move a little bit more depth. Okay, and now we can change a little bit the version to make sure it's with good contact. Now I can move again to anterior, and we have here the implant with a good contact. Let's check if the inclination is okay. The inclination seems to be okay. And here is where I use to check if the implant is correctly in the inferior part of the glenoid. You can see here, if you want also the head, glenosphere, sorry. So it's good to have at least 4 millimeters from the edge of the glenoid. It seems to be okay. If I'm in doubt, I can put it a little bit inferior. And that's what I would want for a reverse total shoulder arthroplasty. This would be the position that I would go for this patient, with the implant a little bit in the inferior part. So that's important. We can check for augmented implants as well. As you can see here, we have very good, very different implants, but I would go for a standard implant. And now I'm going to show how we can do this manually. So let's close the software. We don't need anymore. And now I'm going to go step by step how we do this planning manually. So the first step is to transform the CT scan into a 3D model. So for that, we are going to use a software called Horus. This is the software. This is for Mac only. Horus, it's free. You just need to download. So we are going to import the CT scan just as we did for the Equinox planning software, the DICOM files, click open, copy links, because I don't need to copy the entire exam. And now I'm going to the axial view, okay? And I'm going to choose the smooth part window, which is better. So this is the smooth part window, okay? I'm going to open, double click on the smooth part window. I have it here in my other screen. Let's change here a little bit. Sorry, let's move this window for here. Okay, now it's great. So I have this move part. Okay, with that open, I'm going to select this button over here, which is called 3D, as you can see, and go for 3D surface rendering. 3D surface rendering. There is a small foot here. Now we're going to choose the parameters. For bone is around 170. Just put the pixel value here with 170, and let's check if it's the 3D is okay. So we can check here, it's okay. We can change the parameters a little bit if we want, okay? But for me, this is a good parameter. Now we can see here, we have a 3D model of this patient with the defect here on the humerus. I'm going to export this entire 3D model, okay? So let's here export as STL. Let's export whatever we want to desktop folder. I'm going to show Athens. That's it. We don't need this software anymore. Let's close. We don't need anymore. Now we are going to another software called Mesh Mixer. This software is also free. Okay, Adobe Mesh Mixer you can find for Windows, for Mac, for any platform. We are going to import our 3D model. We have just saved. We saved to the desktop. It's called Athens. Let's open our 3D model. And now we have the 3D model of every bone this patient has on the CT scan. So as you can see here, we have the humerus. As you can see here, we have the scapula, the ribs. So we are going to work with this model as this was an image that we want to cut. Imagine that we have a person that you don't want in a picture, in a photograph, so you want to remove. That's what we're going to do. So we're going to the select tool over here, select tool over here, click on the select tool, and I'm going to select the scapula. So I'm going to put the mouse over the scapula and double click. As you can see, all the scapula was selected, okay? So I want only the scapula. So I'm going to separate this scapula from everything else. So I'm going to edit, separate. As you can see here, we have the scapula and everything else. Scapula in gray and everything else. So in this case, I'm going to delete everything else. So everything else I'm going to delete and work only with the scapula. Now I can do whatever I want. If I want to check, for example, the retroversion of this patient, we can do a plane cut. I'm going to edit, plane cut, and I can do a cut just like that. And I can check how much is the vault of the glenoid, whatever I want. If I want to cut the scapula just like that, I can have a pretty much idea of how everything is doing. If I want to plan a surgery, so now I have to import for this software the implant that I want. So I can import any implant, okay? I'm going to import an implant here. So let's import, append, and let's choose a implant from my folders of implants. So let's go for choose any, we can choose any implant we want. So I'm choosing my folder of implants. I'm going for a different implant. In this case, I'm going for the Evolutis implant just to be very different. So let's go for Evolutis, click no. And now, as you can see here, we have the implant and the scapula. Now we're going to move the implant to the scapula. So let's select the implant here, edit, transform. And now we are going to move it to the scapula. So we're using the mouse to put the implant in the position. So I have to see in many views. As you can see here, I'm going to rotate a little bit, just like that. As you can see here, it's in the inferior part. So we have to put the implant close to our scapula. This is one of the most difficult parts. Let's move here, let's move here, and let's check if everything is correct. It's almost correct. I'm going to do accept, and now I'm going to check if the implant is in a good position. Remember, this patient is a small patient. As we can see here, the implant is going a little bit in the anterior part. It's exiting a little bit in the anterior part. It's not correct in the axis. Let's correct it. Let's change a little bit the retroversion of the implant to make sure everything's correct. It's not correct on the posterior part. Let's move a little bit to anterior. Okay, not good enough. Let's change. As you can see, this is a very small patient, so we have to be careful with an implant like that. So that's the powerful of planning. This is an implant that I would not choose for this patient because it will perforate the vault of the glenoid. So it will be very hard to put this implant in a good position. We can go a little bit more for retroversion, transform. Let's do a little bit more of retroversion of the implant, but still we don't have a very good fitting. So this would be the best position for this implant. The patient would have a very big implant. We can check how is the vault, doing a plane cut, just like that, with the glenoid. Let's select the glenoid, edit, plane cut. Let's cut over here. And that would be how the implant will be in the vault. It's in the center of the vault, which is good, but it's a big implant for this patient. So I would not go for that implant for sure. So this is how we do our planning. Now we just need to export this planning and we have everything done. So this is how we do the manual version of the planning. And the good part of this manual version of the planning that I can export this planning for everywhere. I can export this planning to my smartphone. I can export this planning to a VR glasses, to a AR mixed reality glasses. I can do everything I want. I can export this planning to my 3D printer. I can create guides here for this planning. So this is how doing things manually open our mind to uncountable solutions for helping surgeons performing surgeries. Thank you very much.